Hello, everybody. So it's my great pleasure to introduce Laroyce or Jermaine Covington. He's a PhD student in our program, and he's been working on knowledge graphs with the idea of, well, he will explain, but with the idea of thinking about innovation and how to operationalize the idea of creating new scientific discoveries automatically. So please, Jermaine, go ahead, share your screen, and let's see. I'm excited to see your talk.
Oh, goody, yay. Yes, let me quickly share my screen and figure out how to do that. Share. Excellent. Can everyone see my screen? You should be seeing a white slide with a orange bar at the bottom. Can you see my screen in the front there?
Yes.
Great.
Yes.
So firstly, before we get started, I'm going to ask for maybe a bit of mercy in the sense that this is my first time delivering a presentation to people that I don't already know, especially one that relates to this area of research. So yes, I am intensely nervous. So if I'm talking too fast or if I've not explained something thoroughly enough for you to completely understand, feel free, of course, to jump in or ask questions. I want this to be sort of an open space. And, of course, ensure that everyone is understanding when I talk about knowledge graphs, what I mean and what they are, and hopefully I'll impart upon you how great they are as well. A quick distraction note. Before I started this, while I was working on this presentation, I got distracted a lot, as you do when you're a grad student. And I found myself watching this interview with film and television star Julia Roberts. And she was discussing how she believes that, everyone is connected, by the heart. And it's not a matter of if, but when you'll find your soulmate. And that's such a beautiful idea. And thanks to the power of computers, well, we can sort of model that idea of people being connected to one another and things and concepts being connected to one another. This is Knowledge Graphs in the Science of Science. Hi, y'all. As discussed previously, I'm Laroyce Covington. I've worked with Daniel for the past year or so now on the idea of knowledge graphs as applied to scientific innovation. And I'm going to be giving a bit of an overview as to what is a knowledge graph, examples of what a knowledge graph looks like, the current state of knowledge graph reasoning and knowledge graph research as a whole, as well as specific applications to science of science, with the hope that we can impart a new understanding as to what science of science means and what we mean when we're talking about, for instance, various concepts or various ideas proliferating through the space and so on. But initial question, of course, is what do I mean when I say knowledge graph? And that's actually a very open area of discussion. There's not very much consensus on the exact definition of a knowledge graph. This here is a diagram that I've taken from a paper in this work by Erlanger and Voss, who try to answer that very question of what is the definition of a knowledge graph, because it seems that every time they're brought up in the literature, they kind of have a slightly different definition regarding how big must they be, right? Must they consider an entire domain or a subset thereof, or or the entirety of science, for example? What form must they take? You might hear, for instance, about the resource description framework, which provides a sort of standardized triple format that I'll get into in a moment, or what exactly they must represent, right? So the idea of, like, for instance, things like knowledge. What is knowledge, right? Which is a very deep philosophical question that we do not have the time for. Or, can they represent more subjective matters, beliefs, or does a knowledge graph that doesn't deal with science, is that a valid knowledge graph, or so on? These are all sort of questions that vary depending on who you're talking to. But there are some commonalities in what a knowledge graph is. a knowledge graph, at its base, is a graph of entities and their relations. An entity can be, concept, idea, person, place, thing, what have you. And the set of relations can realistically be anything. And as you can see here, I've created a bit of a rudimentary knowledge graph between myself, Daniel, and Stephen, and centered around this Science to Science summer school. And I'm just going to give everyone a moment to marvel at my abilities with the inbuilt Google Slides drawing tools. Look how amazing that is. But here you can see the various ways that people can be connected to one another via events, such as this Zoom call, or affiliations, or things like, co-citation, co-authorship, and so on. Knowledge graphs are used for many things. I forgot that this slide came after the first one. Knowledge graphs are used for many things. They serve broadly as a knowledge base for information retrieval systems. So Google's knowledge graph is actually quite famous. They arguably popularized the term in the past decade or so, because now when you Google someone, such as I've done on the right here for Bill Gates, you get this wonderful knowledge panel where you get information about where Bill Gates was born and when, or his education, or books he's written. Or, did you know that Bill Gates has been in movies? I didn't, but he has. And look, they're right here. Look how amazing that is. And these are all items that are pulled right from the Google Knowledge Graph, things that are linked to Bill Gates. Bill Gates starred in Pirates of Silicon Valley, or this Twitter account is linked to Bill Gates as a person. All that gets extracted and displayed for you in this nice format. But there's also other applications for knowledge graphs. They can supplement intelligent systems by encoding domain knowledge that'd be costly to learn from data. So when we talk about things like neural networks, right, where you're throwing mountains upon mountains of training data at it so that it can, fingers crossed, learn to distinguish a mountain from a bee or something along those lines, you might want to, include some base knowledge so that it doesn't, freak out, for instance, when it gets like a tree or something along those lines, right? You can show that a bee is broadly this sort of thing and a mountain broadly is this sort of thing, for example. And that ties in a fair bit to things like explainable AI and that sort of research area, where the graphical format, right, the idea of having a set of facts that you refer to is, forgive me, I'm trying to slow down now, is much easier for people to understand, parse through, read, or what have you. And that can also help with things like creating document summaries, or explaining the AI's thought process or something along those lines. There are several examples of knowledge graphs. I mentioned before that Google's knowledge graph is pretty famous, but many of the larger tech companies have boasted about their use of knowledge graphs. Amazon's is called AutoKnow. Meta, who own Facebook, are, of course, talk about their social knowledge graph. You can think about, for instance, the people you may know tab for those of us who still have Facebook accounts. All of these are the product of knowledge graph in some form. But of course, the problem with these company knowledge graphs is that they're proprietary. So they're not public access, right? We can't access them as meta scientists, right? We can't just necessarily go to Google and say, hey, can we use your knowledge graph? Because of course, they kind of keep that very much locked up, and they don't really tell you about how they use that data either, which may or be concerned, but that's an exercise for the listener. But there are linked open data knowledge graphs, and it's this open source nature of knowledge graphs that really kind of caused it to get its footing. The one that I highlight here is Wikidata, which is owned by Wikimedia, who run Wikipedia, which is a knowledge graph, essentially everything that exists on Wikipedia. Everything that has an article on Wikipedia has a corresponding article in Wikidata. And it works in a similar way, right, where anyone can, go in and edit and make changes in that same sort of way. And it provides the basis for several, intelligent systems. What was I going to say? It provides the basis for several intelligent systems. I guess I'll end the sentence there. So when we talk though about like using knowledge graphs in intelligent systems, one of the key components of that is reasoning. And this is important, of course, for scientists as well, because it allows us to, for instance, find potential new avenues for research, which is the basis of the research that I'm doing with Daniel here. So reasoning over a knowledge graph, the idea, of course, being that given a knowledge graph, generating a fact that doesn't exist within that knowledge graph. So for instance, if we were given the facts, Bill Gates was born in Washington, and that Washington is a part of the US, we can infer that Bill Gates was born in the US, right? And that's a pretty simple example. As you can imagine, the most recent up-to-date methods of doing this, are like convolutional neural networks and reinforcement learning and all that sort of stuff, but it doesn't have to be. Ontologies are a common way of enabling knowledge graph reasoning by using these ontologies as a schema layer of sorts. They can define the types of entities that can exist and the ways that those types can interact. So, if we were to say that Bill Gates is a person and, Washington is some sort of subnational entity, well, we can infer that Washington has to be part of some broader national entity, such as the US. And these are, right, and these reasoning methods are a key part of like knowledge graph applications, right, such as differential diagnosis in a medical setting, where you have a series of symptoms that coexist but may not always be present, and therefore we need to infer the likelihood that it is, X disease or Y syndrome or so on and so forth. I've gone through this a bit faster than I thought it was. There are several databases that we can use for science to science, but it kind of comes down as a question of granularity. If we're talking, for instance, on the author level, right, the connections between various authors, right, Daniel advises Leroyce or something along those lines, or the paper level, right, co-authorship or citations, or are we talking about the conceptual level, right? How do concepts within a paper that I've produced, how do those concepts interact, right? Do those concepts interact with ideas that may exist in another paper? And there are several things that can be used to generate, several tools that can be used to generate knowledge graphs, right? Several databases. Of course, I understand that you have had some exposure to OpenAlex already as a part of this summer school program, but I do want to mention things like the Open Research Knowledge Graph, which also provides a similar sort of idea between, having these scientific works and linking them together to the authors and to the ideas that they propose and so on. And I understand that next we'll be talking about the academic family tree. These are all somewhat examples of things that can be considered knowledge graphs, or things that can be approached in the same sort of way that you would approach a typical knowledge graph, or to generate their own knowledge graph, where you can create linkages and connections between people, between works, or between like concepts, people, or between any of those sorts of things. And some fields have actually very much embraced this concept, right? Biomedicine is kind of a big one. I can tell you that it's also used a fair bit in the sort of investing Wall Street kind of space, which I wasn't expecting, if I'm honest. They have a strong tradition of creating these ontologies for interrelated concepts and ideas for the systems that they implement. And I don't mean to, say or imply that knowledge graphs are a perfect thing, right? There are still several open questions in knowledge graphs, right? And I'm just simply talking about 3, but there are actually several more that, for instance, such as modeling data that changes over time. So you may have seen the earlier example that I provided, here, with Joe Biden being president of the United States. Well, Joe Biden was also vice president a few years ago. How do we, encode the fact that these are two separate time periods? There are several, I guess, sort of ways to do that. We can talk about moving away from the triplet format or the fact format where you have a predicate and an object with a relation, and moving toward a sort of quadruplet format where you kind of encode a bit of context as well, such as, time 2009 to 2017, right, as vice president, right, or something along those lines, or having some sort of, like, I guess, like temporal change, or just updating the graph and acting as though the past doesn't exist, which can, I guess, work for some circumstances. Or we can talk about things like fully automatic construction, right? Knowledge graphs are constructed from a body of text or a group of texts, right? And that system still requires some human intervention, right? Fully automatic knowledge graph construction is still kind of an open area, especially when you're dealing with things like specialized information, as we often do in science of science. To validate that system, right, you require specialized knowledge to make sure that your knowledge graph is not making some, connection that's way out there, right? There are very nuanced terms, very nuanced definitions in science that a knowledge graph should adhere to. And thus, if we were to create a knowledge graph that, flaunts those, then it helps no one when we go further down the line talking about, how we can interpret this information, how we can use information to generate new facts, or dealing with missing data, right? We talk about science as never really being complete, right? Scientific knowledge is incomplete. We're always in pursuit of a better, we're always somewhat in pursuit of a better understanding of the universe as we see it, right? Therefore, there's always some incompleteness in what we know. And ideally, of course, with everything that we do, we're trying to, plug little bits of that incompleteness to generate a more complete picture. But in a knowledge graph context, of course, that's missing data. And how do you deal with missing data? That has applications to things like knowledge graph reasoning, as I've mentioned before. But it is kind of an important idea because we want to, of course, make sure that whatever we complete the knowledge graph with is, again, something that makes sense, right? And for general knowledge graphs, for like DVpedia, as I mentioned before, or Wikidata, those things can be more easily validated because it's more general knowledge, right? And of course, there's specialized contributors who are willing to deal with a bit of the harder stuff. But for instance, if we're talking about, biomedicine or physics, I like knowledge graphs, but I'm not a doctor, a medical doctor. I'm not a physicist, and thus, having the time and the ability to, find someone who does that is itself consuming and something that we need to, of course, worry about. Despite this, I do still think that knowledge graphs are a useful tool for representing a scientific domain, and I think that analyzing knowledge graphs can give us key insights into scientific trends, potential future avenues for research. And I didn't mention this earlier because I forgot to put a slide in for it. But the work that I'm working on with Daniel deals with using knowledge graphs as well as sort of definitions of innovation that exist in science of science based on novelty and impact to predict, hey, this might be a new area that we might want to look into, right? There's a link here similar to a link that exists elsewhere that we might want to look into as a potential future avenue for research. And ideally, of course, those sorts of things will be validated then by actual research, right? Going in and investigating the potential connection there. And solving open questions within knowledge graphs, such as representing time or other contexts, such as the prevalence of a certain disease or the particular, like, for instance, biases that may exist with certain facts, will be a benefit ultimately to science research. And I do genuinely believe that knowledge graphs are a way forward when we're talking about how ideas, how concepts proliferate, but also even in the more basic form, how authors and participants in science interact with one another. And I do think that's a way that we could operationalize these sorts of questions. I want, of course, to thank all of you. I can't quite see you guys because I'm screen sharing, but I want to thank all of you for being a wonderful audience. I feel like I've kind of gone through this a bit quickly. So again, feel free to bring up questions that you may have about knowledge graphs and about using them to represent scientific knowledge. I'm open, of course, to questions, comments, concerns. I've been Loris Covington. My information is, of course, available right here on the screen. And I want to thank you again for being a wonderful, wonderful audience for this presentation. That's it. Yeah, I'm done. Yay.
Yeah, thank you so much, Royce. So
I
if there
feel
are any
great. Like
questions,
now that I feel great now that I have validation. I've gotten the clap emojis, which make me feel better.
good.
I'll readily admit, like, I can't see you, so it's sort of one of those things where it's just like, okay, I'm talking.
Yeah, it's a weird.
But yes,
yeah, if there are any questions, please
how do I
raise your hand.
Or
just
put
ask.
it in the chat.
Someone commented about Neo4j as a plotting tool, and also to, well, not necessarily for knowledge graphs, but you can do all kinds of computations with that database, I guess.
Actually,
I don't know if it's a database.
That is actually a very interesting distinction, right? That I feel I may have forgotten to mention, because we had Stephen talking earlier about networks, and there is sort of a distinction almost between networks and graphs that I didn't really bring up. In that networks, you're not dealing with a set of relations, right? There's usually one, maybe a couple of relations, and they vary in intensity. Whereas with knowledge graphs, I'm going to move off of the blinking picture. Whereas knowledge graphs, it's a bit of a broader set of relations, right? You're dealing with the example, for instance, I gave here, right? We're dealing with, for instance, speaking at or organizing or an affiliation, right? Across a diversity of types of node and a diversity of types of edges. And that changes how we can approach, plotting or, even analysis. While many of the same sort of while you can use many of the same sorts of methods with networks and with knowledge graphs, they kind of appear in different forms, if that makes sense. So that actually, thank you, Marcia, for reminding me of that.
Yeah, I mean, I guess it's one thing about knowledge graphs that always, I mean, they're very intuitive at some level, right? It's like, okay, they're capturing this kind of rich, high-dimensional space of relationships, right? And I guess at the same time, as someone who hasn't done anything that gets beyond kind of very, very conservative graphs of the kind I was talking about earlier, it seems like the challenge is really kind of constraining how you design your knowledge graph, right? So I look at Wikidata, for instance, and it seems like there's been a huge and I guess successful effort to figure out, well, what types of relationships are we capturing, and can we do they sort of adequately cover all the types of relationships that matter, right? And I guess I was just curious if in the sort of domain of science, if there are kind of particular knowledge graphs. And I don't know if ontologies fall in this category, or there's an ontology kind of a completely different set of tools. If there's some other science knowledge graph, that would be an interesting place to start, just to kind of explore the ideas some more.
That is interesting. So there is, frustratingly, actually, there isn't like a science of science ontology that exists. I think it would be very cool to have one. But it seems to again be sort of one of those things, a matter of like scale, right? You cover, this is an ontology or this is a knowledge graph for biomedicine or for genomics, right? And only for that. There's not really like an encompassing one for all of science. Perhaps there should be, but it would be an interesting area to, I guess, look into. Yes. I'm not sure if I answered the question.
Yeah, no, it's good to know. I mean, I guess it sounds like it's really a field that is yet to really get going, right? That I mean, I could imagine, for instance, if you have a giant corpus of publications, you could generate a knowledge graph, right, from perform some kind of semantic analysis on publications, and I mean, I guess you see that with some, I guess when people talk about the flavor of citations, for instance, that's kind of getting more than just kind of a simple node connection, but actually kind of some kind of more nuanced relationship between the nodes.
Yeah, like when people talk about, like, whether a citation supports or refutes, a certain point.
Right.
Yes, like that sort of thing definitely falls under knowledge graphs, and it's something that's definitely picking up steam. As I've mentioned, the major tech companies do use knowledge graphs in some form. Right. To some, I guess, I don't want to say controversy, but to some discussion, right, as to whether, it's a knowledge graph or really just a generic knowledge base that they're calling a graph to be cool. But it is an interesting point to make, right, that a knowledge graph, I guess, in a way is more flavorful, to use your words, than a typical network. Not to say that networks are bad or not important, but I guess you could say that.
Right. That's no, I think, I mean, it's right, exactly, and sort of the question you're getting into. So let's see. So there's a question from Sarah. I don't know if you could see the chat. I'd love to hear more about your research, Leroyce, and how you use knowledge graphs. And maybe similar question to mine. Do you have any resource links that you could share?
So I probably would have to think about resources. But I could talk, of course, a bit more about what Daniel and I have been doing. because why are we scientists if not to talk about the world and what we enjoy doing? So the idea, for instance, that Daniel and I have discussed is I always have to take a second to realize, oh wait, no, this is the thing that I do, right? As opposed to what other people have said. So Daniel and I have essentially created a definition of innovation for innovation within science, right? Or scientific innovation, right? That is based on novelty and impact, right? These sorts of ideas, right? Or the idea of innovation, right, permeates for more or less all that we do, determines who gets funded, which is kind of important, but also, what avenues of research that we select as scientists, or priorities for research on the departmental level. And so innovation sort of discusses, innovation sort of defines all that we do, but we didn't really define it for science. And so what Daniel and I have done is that we provided the definition based on the twin concepts of novelty and impact. When I say that, I mean that in sort of the more colloquial sense. There are different ways of measuring novelty, and there are different ways of measuring impact. We can talk about some citation analysis, an application of network science, or we can talk about the mere feature of newness, or some sort of recombinant novelty where a document is novel because it cites semantically distant documents or something along those lines. But regardless of how you may measure it, right, the ideas of something must be new and impactful is key and important, right? And from there, what we have been working on is using knowledge graphs in a way to sort of predict, or I guess give an eye toward innovative ideas. So given, for instance, a knowledge graph of a particular domain, could we use what we know about that domain, what ideas were impactful and not, what ideas were innovative rather in the past? Can we use those to predict future innovative ideas, and what patterns might exist there? It's very much in progress. I know I owe Daniel a mountain of work about it, but it's definitely something that we feel will be a benefit to science. Can I read from the?
Go ahead. No, I just Shady has a question. Shady has a question for you.
Yeah, I wasn't sure of the dynamic, if it was like, oh, are you guys going to read out the question, or can I just go and address it? One of the challenges in science is named disambiguations of authors. Have knowledge graphs been used for addressing this issue? Yes. Especially when you consider things like, for example, ORCID, which I mean, I don't know if y'all have one. I have one, despite having no publications. Right. So when you consider things like ORCID and implementing those ideas as unique identifiers for authors, or linking rather individuals to their ORCID, knowledge graphs have been used for disambiguation. In terms of, without that, you kind of come up against the, I guess, sort of the issue of people with the same name, and with people with the same name, the disambiguation problem. I am aware of some projects where like you can have multiple people with the same name, but for instance, the connections that are made, right, you know, the field that they're in or their affiliation are used to disambiguate them as well. Those do exist. Those are used, right? And I think knowledge graphs are particularly useful, for instance, in that area. And I hope I adequately responded to your question. Knowledge graphs are particularly useful for that area. I haven't worked with OpenAlex. I believe OpenAlex actually is one of those things that actually kind of works at that, but I'm not too sure. I'm not too sure. Yeah.
So I guess you could think of OpenAlex as a knowledge graph, I guess. Is that...
Well, yeah. And actually, I was on the OpenAlex site earlier to get their logo, and they do discuss their potential for. They don't build themselves as a knowledge graph, but rather, I guess, as a tool to generate knowledge graphs. But I was actually surprised to learn, because again, I haven't worked with OpenAlex particularly extensively. That's more Li Zhen and his work. But I was particularly surprised actually to learn that they do have conceptual tags within OpenAlex. You can map concepts, which makes me really want to work with OpenAlex now. And it's sort of one of those things where it's like, okay, I almost got distracted working on, like, trying to play around with this. I can't get distracted. I had a presentation to do. But you know, but in the same way, I forget where they had mentioned the disambiguation issue, but they do have a similar method, right? Again, using sort of knowledge graph reasoning methods to disambiguate authors, or I guess they recommend certain ways that you can disambiguate authors using that. OpenAlex is cool. Use it. That's another conclusion. We'll add that as a bullet point. Are there any further questions or comments before I go? Give people a minute.
No, that's great. Thank you. That's yeah, no, it's a really nice sort of overview, and I feel like I now have a better sense of what knowledge graphs are. So really appreciate it. And yeah, and I think we'll be seeing a lot more of them, sort of that idea developing in the future. So it's great to kind of see the idea in its essence.
Yes. Well, in which case, I guess, thank y'all. I'll be, of course, here if you have any further questions, you know, around. I'm in the Slack that we have